So let us start second derivation. Derivation 2, as per CBSE boards, we are going to discuss from the NCERT book. So the derivation number 2 is electric field due to charged spherical cell or hollow sphere. Spherical cell or hollow sphere mean the same thing, or it can be or metal sphere. Okay, these all relate to the same thing. So first is the spherical cell. For the spherical cell, you can understand that inner and outer radius is almost the same, no difference. Hollow sphere, it means that there is inner and outer radius is there, and that is also, you can say, not the same. But hollow sphere sometimes can be treated as spherical cell if the inner radius and outer radius are not mentioned as different in the question. And also definitely we can talk about metal sphere. So metal sphere, whichever case, whether it is hollow or solid, doesn't matter, both. So I'm writing here both. If it is a metal sphere, then it is both hollow and solid. Okay, so if it is a metal sphere, so doesn't matter if it is a hollow or solid. So for all these cases, for this one, this one, this one, okay, so for all these cases, this derivation holds good enough. So let us discuss. This is the sphere and the radius is r. I'm taking the radius as capital R. Okay, so one thing I would like to tell you that in all these cases, the charges are present only on the surface. The charges are present only on the surface. Okay, there is no charge inside the volume. Okay, please try to remember this very important case. There is no charge inside the volume. Zero charge, no. No charge inside volume of radius r. Okay, so this is very important point, that there is no charge inside the volume of, no charge inside the volume of radius r. Okay, there is no charge inside, so all the charges are present on the surface. Okay, all the charges are present on the surface, and let us consider that surface charge density sigma is equal to constant. Let us consider this thing, that sigma is the surface charge density, and the sigma can be written as charge upon area. Okay, and so the SI unit of sigma can be said as coulomb per centimeter square, coulomb per meter square. Okay, this is the SI unit of sigma, which is surface charge density. Okay, this sigma represents surface charge density, surface charge density. Now, what this surface charge density means? So it clearly means charge divided by area. So if you think about, the total charge is Q and the area is 4 pi r square, which is the total curved surface area of this sphere. So this can be said as sigma, and obviously what is sigma? This sigma is constant. This sigma is constant. Okay, so like this we can discuss the expression, sometimes in terms of sigma, sometimes in terms of Q. Okay, so starting with the expressions of the electric field, which is the second derivation. So we'll choose three different positions. So first is inside point 1, second is on the surface, and third is outside. So I've chosen three different points where we want to find electric field. So let us consider this point 1, which is the inside point. So this is the distance from the center. For the point 2, this is the distance from the center, and for the point 3, this is the distance from the center. Okay, so accordingly we will discuss the values of electric field here. So let us try to put a common expression, that is small r. Small r is equal to distance from the center. Small r is the distance from the center. Okay, so clearly we'll try to understand that for the case 1, here the small r will be less than capital R, as you can see here. But for this third point, small r will be greater than capital R. Okay, and for point number 2, obviously small r will be equal to capital R. You can write here small r is equal to capital R. You can think like this. Okay, so this small r is a general term. It is a representative of distance from the center, and distance from the center for the point where we want to find the electric field. Okay, so let us consider that can be any point. It can be here, it is point P. It can be here, this is point Q. It can be here, this is point R. So these are the three different points which can be inside point, surface point, outside point. Okay, so we will try to discuss the expression of electric field at all the points. Okay, I hope you have understood this. Now let us talk about something for the inside point. Okay, so let us talk about for the inside point, that is point P, which is the inside point. And clearly small r will be less than capital R. So clearly we want to understand that what will be electric field at this particular point number 1. Okay, so this is point number 1, you can say, because I also named them with numbers like number 1, number 2, number 3. So okay, fine, that's just the representation, doesn't matter. So let us think about the equation. So first of all, you'll say that electric flux has got two formula. First is charge enclosed upon epsilon naught, and second is E dot S. Okay, so these are the two expressions of electric flux. So how do we think about this first point actually here? So here clearly for this point 1, charge enclosed is equal to 0, because there is no charge inside this bulk, inside this volume. All the charge are present on the surface. So if this is 0, you can clearly see here from the expression that this charge enclosed is 0, and further this expression could have been written as Es cos theta. So if charge enclosed is 0, clearly electric field will be 0. Okay, so this is very important. Electric field will be 0 for all the points which are inside this sphere, that is having the distance less than capital R. Okay, so that is the point number 1. Now we'll move for the point on the surface. Now second thing for the point Q. Point Q is on the surface. It is not the inside point. It is the surface point. It is the surface point, you can see here, and it is having point number name, that is point 2. Okay, so now here let us try to understand this. Small r will be equal to capital R, and here in this situation this is not equal to 0 definitely. Okay, because charge enclosed can be written as capital Q. This charge enclosed, this total charge is present on the surface, and this is denoted by sigma, and we know the value of sigma also. So clearly we can write sigma in terms of Q. Q is the total charge Q which is spread on the surface. So sigma can be written as Q upon 4 pi capital R square, and this is said to be constant. So clearly this is the expression of sigma, which is the surface charge density. Okay, now let us talk about the expressions. So here if we put for charge enclosed is Q upon epsilon naught, and here is E, and S is the surface, S is the entire surface, because at this particular point here area vector is this side, and electric field is also radially outward. Electric field is radially outward, area vector is also radially outward. So the angle is theta 0 degree. Angle is 0 degree, cos 0 degree is 1. So E into S, and S is simply 4 pi R square. S is simply 4 pi R square. S is the total surface area. Okay, that is 4 pi R square for the point which is on the surface. Example, this is the point Q. The name of the point is Q, and total charge is also I have said as Q. Q is the total charge. Q is the total charge which is on the surface. Okay, so now here we can easily correlate that E can be written as Q upon 4 pi epsilon naught R square. This can also be said as KQ by R square. Okay, because K can be written as 1 upon 4 pi epsilon naught. This is the expression of K. Okay, and if we talk about this expression, it is converted to this form. So this is the KQ by R square. Remember this formula, and also this formula can be converted in terms of sigma. So in that case the formula comes as sigma by epsilon naught. You can remember both the formulas. You have to remember this formula, you have to remember this formula, both the formula you have to remember. Okay, how this one got converted to this, I'll explain you. So this upon this is written as sigma. Okay, this upon this is written as sigma, so it becomes sigma by epsilon naught. So electric field on the surface point is KQ by R square. Okay, also it can be said as sigma by epsilon naught, where epsilon naught is a constant. I have to remember its value, 8.8 into 10 raised to the power minus 12 in terms of SI unit. So let us try to remember this. In exam also this value is given, but if you remember it is not bad. Okay, now let us come to the last point, which is outside the surface. So last point is for the outside point. Outside point is point number 3, or that's denoted here by the point R. So for this case I have already mentioned that the distance from the center small r will be greater than capital R. This R is simply the name of the point. Okay, so don't be confused here. Okay, so the outside point is point number 3 for this case. If you try to think about the formula, so flux can be said as charge enclosed upon epsilon naught, and this is equal to ES cos theta. Okay, now for this third point also, if you try to draw a Gaussian surface, because in the uses of Gauss's law, we have to draw the Gaussian surface. So for this point 3, if you draw a Gaussian surface, let us say it is done like this. So clearly the charge enclosed is once again the same. Charge enclosed is the same. Okay, but the value of S, which is the surface area, it will be changed, because this time the surface area will be greater than the previous surface area, because this small r is greater than capital R this time, and theta is once again 0 degree, the same value of theta. Okay, electric field area vector both radially outward. So this is one. So no problem. Electric field now comes up as kq by small r square. Here it is not capital R, here it is small r. Okay, and also the expression can be said in terms of sigma. The expression can be turned in terms of sigma is the sigma r square upon epsilon naught small r square. So this is an important expression. You have to remember this part also, and you have to remember this part also. Okay, both the parts you have to remember. Okay, so this is for the third point. Now I will try to make a graph. अब मेरे को ग्राफ बनाना है, ठीक है? क्या बनाना है? ग्राफ बनाना है, जैसे कि कल ग्राफ बनाए थे. तो let us try to make a graph for 3 different points. Let us make it on a single graph. So see, I'll try to understand the variation of electric field with the distance r. So for the inside point, electric field is 0 simply. For the point on the surface, electric field is simply proportional to r square. So it is in fact constant. Electric field is constant. Okay, because the radius is also constant. And then if we talk about the outside point, so the outside point electric field is inversely proportional to distance square of distance. Okay, so let us try to make the graph. The graph looks simple like this. This is electric field and this is small r. And what was small r? Distance from the center. So let us try to make the graph. So inside, that is from the center. Okay, let us consider it O, origin, and here let us say the distance is equal to the radius, and this is the value of electric field at that time, kq by capital R square, or it can be written as sigma by epsilon naught. Okay, both are the same expressions. And now if you think about the graph, it will be like this. Like from here to here there is no electric field. Now it has got a constant value. I would say this is the value. Okay, so from this point it is coming like this. Electric field is inversely proportional to r square, and here it had got a constant value, and that value will be equal to kq by capital R square or sigma by epsilon naught. So this you have to remember, very important. Putting the values, I am writing here. The values here. Kq upon small r square, like in terms of small r, in terms of capital R, like this, or you can write here sigma by epsilon naught. Okay, and here obviously, here you can write sigma capital R square upon epsilon naught small r square. Okay, so try to remember it this way. That's all for the second derivation. Simply we'll discuss derivation number 3. Thank you.